synthesis of amino acids. One of the oldest methods of alpha amino acid synthesis is the Hell-Vollard-Zielinski reaction, or HVZ reaction. So it begins with the bromination of a carboxylic acid. For instance, we have the methylpentanoic acid with bromine, a bromide, and a uh, phosphorus bromine and phosphorus. Okay. I mean, so after bromination, we will have the nucleophilic substitution of the alpha and bromo acid with ammonia, and then it will yield to an alpha amino acid. Okay. Okay. So from 4-methylpentanoic acid, nagkaroon tayo ng bromination with this compounds, with these molecules, and then we will have this product. So yung mapapansin nyo, yung isang H, kasi dapat ganun yan, di ba? H ito, H ito. Ito na yan ha, yung H2. Ganyan na yun ha. Okay. Now, yung isang H ay napalitan ng bromine. Ayan. Kaya naging isang H na lang siya. Ayan. Naging isang H na lang. Now, after bromination, we have nucleophilic substitution of the alpha bromo acid with ammonia. Ayan. So, ni-replace ng NH3 ng ammonia yung ating bromine. Kaya nagkaroon tayo ng ganitong amino acid. So, this amino acid is leucine. So, from 4-methylpentanoic acid, and we had HVZ reaction, it yields to a leucine amino acid. Okay. So, worksheet number 10, show how you could prepare alpha amino acids from the following appropriate carboxylic acids. So, you can Google the tawag nito, condensed form, ganyan, condensed structure of phenylpropanoic acid and methyl butanoic acid. And then you will name the amino acid, the amino acid of the synthesis, no? Tama ba? Yung product na amino acid ng synthesis na yun. Okay? So that's your worksheet number 10. Okay. So another synthesis is the amido-malonate synthesis. So it is a more general method for preparation of alpha amino acids. So the reaction begins with conversion of diethyl acetamidomalonate into an enolate ion by treatment with base. Okay. Ayan siya. So, ito kasi kanina is COOH. So, ginawang enolate ion. So, ngayon, nawala na yung H na yon. Kaya, may letter ET na siya. So, ibig sabihin, meron siyang, ginawa siyang enolate. Yun nga, ion. And now, after nun, so, it is followed by the nucleophilic alkylation with a primary alkyl halide. Ayan. So, ang halide natin dito is bromine. Okay. So, ito daw yung dapat na meron siyang side chain. Okay. So, after the nucleophilic nucleophilic substitution, so there would be a hydrolysis of both of the amide protecting group and the esters. Okay. So, meron daw tayong hydrolysis ng ating, this one, yung ating protecting group sa ating sa ating amide, which is yung NH. Okay. So, at din yung ating esters. Ito. So, siya yung maaalis. Okay. Nagkakaroon tayo din ng decarboxylation. Ayan, ito nga yung ating, ang tawag nito, yung ating COOH, decarboxylation. Kaya nagkaroon tayo ng aspartic acid. Nawala yung ating, wait, let me clean that. Nawala ito, napalitan ng hydrogen. So, nag-donate itong ammonia natin. And then, yung NH natin, yung, ang tag nito, yung dalawa na naiwan dito sa ating ammonia ay nag-donate doon sa ating amino group. At naalis yon ating carboxyl group kasi nagkaroon ng decarboxylation. So, paano ba natin gagawin ito? No? Paano natin gagawin kung ang given ay amino acid? So, show how you would use the amido-malonate synthesis to prepare a race mixture of leucine. Race make, ibig sabihin 50-50. Okay, mixture of leucine. So, sabi, let's begin by identifying the side chain attached to the alpha position of leucine. So, saan ba yung alpha carbon natin? Diba ito? So, ang side chain niya would be this one. Hindi kasama itong ammonia ha, because that's the amino group. So, ang side chain natin is this one, CH2. This one is CH. Tapos, may nag-branch out sa kanya na CH3 na methyl. And may nakakabit din doon sa isa nating carbon, yung ito na CH3. Ayan. So, after we identified the side chain, we will identify the alkyl halide needed to install this group. So, dito sa ating amido-malonate, since bromination, ikakabit natin siya ngayon sa alkyl halide na bromine. Ayan. So, in condensed form, magiging ganito siya. So, Br, CH2 is this one, CH is this one, and then, yung sa CH, may nakakabit na CH3, and meron din nakakabit na isa pang CH3. So, ganyan siya. So, now, we can now start the amido-malonate synthesis. So, eto muna siya, yung lahat ay nagmumula sa, sa diethyl acetamidomalonate. Ayan. Okay, so ito yung ating acetamidomalonate. And then we react it with these molecules. Ayan. But as you can see, dito na natin nilagay yung side chain na na-identify natin kanina. Okay? Yung BRCH2, eto na siya. Ay, wait lang. So, eto na siya. Diyan nyo ilalagay pag mag-amido-malonate synthesis na kayo. So, now, nagkaroon tayo ng, call this, ng nucleophilic substitution. Ayan. So, yung H, ayan, yung H na to ay pinalitan natin ng ating side chain. Ay, sorry, walang BR. Ay, tama pala, wala pala talagang BR, sorry. So, ito, ngayon, yan. Tapos ngayon, yung ating side chain ay nandito na, nakakabit na siya sa ating carbon. Okay? So, after that, introducing or yung parang substitution, nucleophilic substitution. So, meron na tayong ganito, no? So, magkakaroon naman tayo ng hydrolysis. So, yan, kasi may presence of heat. At nagkakaroon tayo ng decarboxylation, diba? So, ngayon, nawala na yung protecting group natin doon sa ating amino group. Nagkakaroon tayo ng decarboxylation. Nawala na to. So, itong hydrogen, nag-donate siya ng dalawang hydrogen sa ating amino group. At yung isa ay denonate dito sa ating carbon. Kaya, ganito na siya. Ayan, naging ganito na siya. So, this is your side chain This is your alpha carbon, this is your carboxyl group, and this is your amino group. So that's how you show the amido malonate synthesis of a amino acid. Okay. Now, there's another method for the synthesis of alpha amino acids by reductive amination of an alpha keto acid with ammonia and and a reducing agent. So, alanine for instance. So, alanine is prepared by treatment of pyruvic acid with ammonia. Yan. In the presence of sodium, ano ba to? Borohyd, hydrogen ba ang NaBH4. Nalimutan ko na. Ayan. Now, so the reaction proceeds through formation of an intermediate imine, which is then reduced to produce an alanine. So that's the reductive amination of alpha keto acids. So hindi ko na yan, di na ako magbibigay ng worksheet on that kasi medyo madugo din siya. Okay. Sorry. So let's have the, wait. Oh, sorry. Okay. So let's have the enantioselective synthesis. Ayan. So, ang enantioselective synthesis is a method that is used to prepare only the desired enantiomer ng ating amino acid. Siyempre, ang gusto na i-produce natin is yung parang naturally occurring. So, ang mga naturally occurring amino acid has an S enantiomer. Diba? Ayan. So, ang enantioselective synthesis was discovered by William Knowles some years ago, and he found out that alpha amino acids can be prepared enantioselectively by hydrogenation of enamido acid with a chiral hydrogenation catalyst. So, ano ba yun? Ayan. So, pwede daw tayong mag-prepare ng amino acid by taking or by breaking this double bonds from this molecule. Pwede daw tayong mag-prepare ng amino acids. Okay, now. So, sa enantioselective synthesis, the most effective catalyst for this method are the coordination complexes of rhodium, RHODIUM, with 1,5-cyclooctane or yung COD, and a chiral diphosphines such as RR12 bis o anisylphenyl phosphinoethane. So, the so-called dye pump. Ito lang yon. Wala lang, shinare ko lang. So, yan yung catalyst ng ating enantioselective synthesis. So, unang-una, nagkakaroon tayo ng hydrogenation. And when we have hydrogenation, nabibreak yung double bond sa ating enamido acid. So, we have this enamido acid. At nung nag-hydrogenation tayo with the help of our catalyst, ang nangyari is na-break yung double bond. So, naging single bond na lang siya. Okay? So, may nagdagdag na H. So, itong C na ito, wait. So, itong carbon na to, ay ito siya, Ayan, kung saan. Ito siya. Ayan siya. And this one is this one. And this one is this one. Yan, ganun lang siya. Now, ano tong AC? That's acetate. That's COCH3. Okay? So, after hydrogenation, so nagkakaroon naman tayo ng um, chiral hydrogenation naman. Ay, ano, tama. Chiral hydrogenation naman. Okay. Okay. So, at yung last time pala is chiral hydrogenation, sorry. And this one naman is hydrogenation on our amino group. Okay. So, we have these reactants. So, yung acetate, nakuha, and, ayan, napalitan ng H2. Parang what do you call this? Nag-donate ang ating ammonia ng H. Ayan, kaya naging H2 na siya. So, ganun ang enantioselective. Okay. So now, let's show how we could prepare the this amino acid. For example, this is leucine enantio selectively. So, let us first identify the side chain. So, ito ulit. So, ito yung side chain niya. NH is not a side chain because that is an amino group. So, ayan. So, ito yung kaninang enamido acid. Ayan. So, ito na yung side chain niya. Ayan siya. Okay? Okay. Balik tayo. CH2. Wait lang. CH2, CH, na may nakakabit na CH3, at may nakakabit pa na CH3. So, ganito siya. Ayan, diba? Ito na yung side chain. This one. Ayan. So, napansin nyo na nawala yung H na isa. Diba? This is CH2. So, napansin nyo na nawala yung H kasi nga, double bond. So, 4 lang na bonds ang meron sa carbon. Okay? So, now, ayan, nagkaroon tayo ng chiral hydrogenation. Kaya, na-break yung double bonds at nagkaroon tayo ng isa na lang na bond. And, bumalik yung kanyang isa pang hydrogen. Okay? So, after chiral hydrogenation, meron na naman tayong hydrogenation on our amino group. Ayan. So, as you can see, naalis lang yung acetate natin at napalitan na siya ng NH3+. NH3+, yung sweater ion na lang yung na din yung ginawa ko. Pero you can answer by just putting 2. So, NH2. Yun ang medyo mas correct. Mali lang siguro talaga ako. Ayan. So, now, ayan. So, let's compare our product with the structure of leucine. So, as you can see, COO. So, our chiral center, which is this one. So, ito yun. So, kulang pala ako ng H. Dapat may H pala siya dyan. Sorry, ayan. So, ito, may H. Tama. NH3. Ayan, tama. So, on this one, So, on this one, yan yung kanyang side chain. So, we had the correct, correct process on the enantioselective synthesis of leucine. Okay. So, in worksheet number 10, show how you would use the amidomalonate synthesis and enantioselective synthesis to any 3 amino acids of your choice for each synthesis. So, same yung 3 amino acids para doon sa amidomalonate at enantioselective. Okay. So, that's our amino acid lecture.